My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with a Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. You are welcome to episode number 41 of the 120 Days to Jamb Physics with Flash Isaac. In this episode, we shall be looking at questions under vapours and humidity. You will agree with me that we've done a lot when it comes to vapours and when it comes to humidity and relative humidity. Let's begin with this question. It says, the following is a table of saturated vapor pressure of water from 10 degrees Celsius to 50 degrees Celsius. Saturated vapor pressure of water. Let me throw another light on saturated vapor pressure so that when you hear this word, it makes more sense to you. If this is a container, this is your stove or gas or source of heat, and the water level is here. Look at this. If this water continues to get heated, when it gets to 100 degrees Celsius, it begins to evaporate. It escapes and it evaporates into the atmosphere or into the air. Now imagine a closed system. If we close this at 100 degrees Celsius, this water will boil and it will keep evaporating. What happens? At the top of this water or the top of this level, you see water vapor escaping. This process is referred to as evaporation. Change of state of matter from liquid to gaseous state. What happens? As you continue to boil, this water in gaseous state comes. It continues to evaporate. When it gets here, it can no longer escape. It can no longer evaporate. What happens? There's what we call collision. These molecules, they collide with themselves, back. The molecule of the gas or the gas molecule collide with themselves and they collide with the containers. I discussed this under kinetic theory of gases. The molecules collide with themselves, back, and they collide with this container or the containing vessels. What happens? After much collision, some of these molecules, they get so tired, and by the time gas molecules get tired due to collision, they go back to liquid state. We call that condensation, which is change of state from gas to liquid. Evaporation from liquid to gas. Now, this evaporation and condensation, they happen together. Evaporation, condensation, until equilibrium is reached. What happens at equilibrium? At equilibrium, the number of molecules of this vapor remain constant at constant temperature. So, at constant temperature, the number of molecules of this vapor will remain constant. As such, we say that equilibrium has been reached. Now look at this. Even at equilibrium, the pressure that this gaseous state is exerting on the liquid is referred to as the vapor pressure. Vapor pressure. Because this vapor, as it's hitting the containing vessels, coming down, as evaporation and condensation is taking place in this vapor stage, it is putting pressure, it is mounting pressure on this liquid. So that's what we call vapor pressure. Now, this vapor pressure is saturated when equilibrium is reached. At equilibrium, the rate of evaporation and condensation are equal. Just the way the rate at which evaporation is taking place is the same rate at which condensation is taking place. So if this vapor pressure exerted is at equilibrium, we therefore say that it is saturated vapor pressure. I hope when you hear saturated vapor pressure of water, you understand that it is the pressure which the gaseous state of water mounts on the liquid state at equilibrium. Now, they gave us different temperature: 10 degrees, 20, 30, 40, and 50. And they gave us the saturated vapor pressure of water in millimeter mercury, I guess. Now look at this. At or centimeter mercury. Centimeter mercury. Because the questions here, or the values here, are also in centimeter mercury. At 10 degrees Celsius, this pressure the gaseous state of water mounts on the liquid part at equilibrium is 9.2. At 20 degrees Celsius, the saturated vapor pressure of water was given to be 17.5 centimeter mercury. At 30 degrees Celsius, the saturated vapor pressure of water was given to be 31.8, and so on. So this is a general knowledge of what they want us to know. At this temperature, this is the pressure, vapor pressure of water. So what are we going to do with this information? How does it change the price of garri in the market? Let's look at this. On a very good day, when the atmosphere pressure is 75.85 centimeter of mercury. Atmospheric pressure is denoted as H, big H, big H. They say it is what? 75.85 centimeter of mercury. Some water vapor is present in a barometer tube which reads 72.67 centimeter. The barometer is an instrument used to measure vapor or atmospheric pressure or saturated vapor pressure. You use the barometer to read it. Now, they've used the atmospheric pressure is this, but when the reading was done using a barometer, the result we got was 72.67 centimeter of mercury. This is the result gotten when barometer was used to take the reading. And the barometer reading is noted as small h. And they said, so what is the temperature of the surrounding? What is the temperature of the surrounding? Look at what this question is all about. We have atmospheric pressure and we have barometer reading. So, what is the temperature of the surrounding? The temperature of the surrounding will be determined by the saturated vapor pressure of the surrounding. So, how do we find saturated vapor pressure? This is the formula you must know. Atmospheric pressure is equals the barometer reading plus saturated vapor pressure. Take note of this formula anytime, any day. So, to find saturated vapor pressure, it is simply the atmospheric pressure minus barometer reading. And that is 75.85 minus 72.67. This will give you 31.8 centimeter of mercury. This is the saturated vapor pressure. Now, going to the table, when saturated vapor pressure is 31.8, the temperature will simply be 30 degrees. So the temperature of the surrounding is 30 degrees because the saturated vapor pressure is 31.8 and it corresponds to the temperature 30 degrees. The next question here says, why does pressure cooker save both time and fear in cooking? I already explained this in one of the episodes. In fact, in one of these recent episodes, I said that At 100 degrees Celsius, water begins to boil. And what happens? As water begins to boil, the next thing is evaporation, change of water state from liquid to gaseous state. Now, as evaporation is taking place, the temperature of water is basically not increasing. You see more of the water vapor just begins to escape. Now look at this. For pressure cooker, it works by increasing pressure. Now as pressure increases, the boiling point of water increases. So pressure cooker acts to increase the boiling point of water. As boiling point of water increases, even after 100 degrees Celsius, water will not boil and it will not escape off. All the water still remains, but it gets hotter and hotter and hotter. This extreme hotness will definitely make the food to cook very, 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 very fast. What is common between evaporation and boiling? Evaporation is change from liquid to gaseous state, and evaporation is a surface phenomenon. It happens only at the surface, while boiling occurs all over the liquid. Now evaporation can also happen at any temperature at all, but boiling will definitely happen at a particular temperature. For water, 100 degrees Celsius. For every other liquid, they have their boiling point. I think alcohol should be around 78 degrees Celsius boiling point or so, if I'm not. Now look at this. What is common between evaporation and boiling is that they both involve change of state. The change of state will happen along the line, and change of state from what? From liquid to gaseous state. Small droplets of water that forms in the grass early of the morning is referred to as dew, D-E-W. And the phenomenon whereby water droplets in the atmosphere combine with dust particles in the air to reduce visibility is referred to as fog. Fog, F-O-G. Now let's look at further questions before we call it a day. And mind you, all these are just to refresh your brain. The main questions are in the Flashlearners application. Install the app and play with questions. You can actually choose a topic. Under topics, go to Vapour. You will see all the questions under Vapour, answers, explanations, school finder, a lot of features that will completely blow your mind. It says the mass of water vapor in a given volume of air is 0.05 grams at 20 degrees Celsius. And while the mass of water vapor required to saturate it at the same temperature is 0.15 grams. Calculate the relative humidity of the air. This should not be a problem to us at all. And no question under relative humidity is actually difficult for you to answer. Remember, I told you that relative humidity is equals the water vapor present in air, the mass of water vapor in air, mass of water vapor present in air over the mass that is required for saturation, the mass needed to saturate the air, the total mass, the total vapor that the air requires. So which is the mass required for saturation. We also say that saturated vapor pressure is simply the pressure at dew point over the pressure, the air pressure itself, the pressure at dew point over the air pressure. Now let's do with what we have. This is enough. Now the mass of water vapor in air or the volume is given as 0.05 grams, 0.05 grams over, we said that, or they said that to saturate the air we need 0.15 grams at the same temperature. So this is 0.15 grams. Dividing, you should get 33.33%. Now this is the same thing as 0.0, this is something as 0.5. You pick from here. Since here is 0, you start counting. 1, 2. 2 times is 100. This is 0.5 over 100 or 5 over 100 divided by, pick after the decimal point, that's 15 over 1, 2. You moved twice to get to the end of that one, so that is 100. This is the same thing as 5 over 100 times 100 over 15. To change division to multiplication, you invert the other side. So 100 cancels 100, and this is equals 5 over 15. Remember, we are dealing with it in percentage. This is times 100%. So 15, 5 over 15 times 100 should give you 33.33. Relative humidity is also SVP at dew point over SVP at air temperature. Please don't forget, we are multiplying by 100 times 100 times 100. So let's look at the next question. It says, calculate the relative humidity if the saturated vapor pressure of water at 12 degrees Celsius, and it means this 12 degrees Celsius is the dew point, and 26 degrees Celsius air temperature. It means 26 degrees Celsius is the air temperature. So they are 10 millimeter mercury and 19 millimeter mercury respectively. Let's simplify this question. It means at dew point, the pressure is 10 millimeter mercury. At air temperature, the saturated vapor pressure is 19 millimeter mercury. With this, we have what we want or what we need to calculate relative humidity, because apart from mass of water vapor in air over the mass required for saturation, relative humidity is saturated vapor pressure at dew point. So dew point here is 12 degrees Celsius, and the pressure corresponding to it, or the saturated vapor pressure at this dew point, is said to be 10 millimeter mercury. So that is 10 over, and the air temperature according to this question is 26 degrees Celsius, and the pressure, or the saturated vapor pressure corresponding to the air temperature, is 19 millimeter mercury. So this is 10 over 19 times 100, and this will give you 52.6% if we are correct. Ladies and gentlemen, with this, we come to the end of this episode, and I do hope you found this interesting. Please get the Flashlearners Jamb app and begin to play with questions. And don't forget to follow these episodes and tell all your friends about the Flashlearners YouTube channel. See you in the next episode, and do take care of yourself.